be assigned later today, but both are due Sunday the 26th, and then because of exam next week, you guys won't have any homework next week. So that should be good. Exam is the 29th, class time in here, so you know where to go. And then the previous Monday I'll be doing a review, so you guys can either put questions on Slack or ask me questions during class about any types of questions or concepts we'll cover on the test. And then around Wednesday I'll come out with a study outline of what topics we'll be discussing. And then one person online, I'll get to your question in a second. One person online asked about what can you do to study. So one is to review the homework, see anything that you missed, the quizzes too. Those are both important. But also if you want to do like any of these questions that are in the backs of the exams, these are also good prep on the concepts and tools that we've discussed so far. And then once I have the study guide released, then you'll be able to study on those topics further. Yes?
Is part of the test going to be take home?
Yeah. So there's going to be a 50% in class, which you'll have 50 minutes to do. And then the other part is a take-home exam. That'll be due the Sunday before we come back from fall break. Yes?
Are questions going to be like short answer or like multiple choice?
There'll be some multiple choice, and I believe at least a couple short answer that on the open book. On the closed book, it'll be more working with jump and longer questions as well. Yes?
Is the take-home part?
It'll be just like a turn-in like you do for a regular assignment on Canvas.
Okay.
So the Word document or whatever will be there. It won't be like a timed exam in Canvas. It'll be like an assignment.
Okay.
Anybody have any other questions? And so today's and this chapter's content will be the last ones that are on this exam. So covering chapters, a little bit of 1, 2, 3. We did like one miniature thing about categorical variables, and then chapters 5 and 6 will be on the exam. All right. So for today and on Wednesday, we'll be talking about how to come up with different types of experiments and how to tell the difference between observational studies and experiments. So we are going to learn how to be able to distinguish between an experimental study and observational study. Be able to explain the relationship between explanatory variable and response variable. So we've kind of already done this when we talked about variables in chapters 3 and a little bit of 4. But I'll go a little bit more into what each of these are. Be able to design a sound basic experiment. How to be able to design a sound observational study. So how to design these methodically so that you reduce any chance of error. To understand the relationship between research design and established causation. So if you remember before when we had these relationships and we just did these exploratory data analysis charts, the only thing that we could learn was association and not causation. And so with sound research and experimentation, you can actually develop a causal link if you control for other variables. But if you don't control for these, and there's other types of variables out there like confounding and lurking variables, I'll talk about that later today, these can highly affect the outcome of a study. And kind of last two here, how to apply different experimental designs as it means controlling these confounding and lurking variables. And so just by the kind of negative nature of confounding and lurking, these are variables that you do not want in your study. And lastly, you want to be aware of and take steps to overcome various challenges in these research studies. So to start off here, we're going to talk about experimentation and observational studies. And so let me just put the two up here. So an experimental study involves some type of treatment that you need to modify or provide conclusions about your results. And so down here in the experiment, we have treatments. Has anybody seen a treatment being used, either an article or something you found online that people are trying to control for? Anyone give me an example of a treatment in a study?
That'd be like animal testing for like a toiletry product or something.
Yeah, like if they specifically use the product or not, right? What are you trying to talk about with your animal example?
Maybe I'm totally wrong and I'm like
No, go ahead, you're fine.
going down the wrong path, but just like, I don't know, like they test products on animals and use them on animals, like have them like ingest them and all this.
That's right. So testing products on animals. And specifically, where they employ this is they have some animals take it and they compare to animals that don't. So this is a type of classical type of treatment that many people do, is that they'll give one set of the population a treatment and they'll give the other set no treatment at all, or placebo. So this is known as a placebo study. This is placebo because they still give them a pill or whatever, and especially if it's humans, if they know that they're in a study to take a treatment, they might think, oh, I'm just going to feel better after the sugar pill. And so here will be the actual treatment. Other examples that I have here are drug trials, psychological studies, educational interventions, and so a lot of them, and this is usually known as the control. So control study, what would happen if we didn't even give them any treatment? All right, so here we have experiment, and I'm gonna actually erase this up here and put it on the other side. So, observational study. Okay, so when you guys look at the word observational, what word comes to your mind? What smaller word of observational? Observe, right. So, when we're looking at this, this is the key word here. And what do we do when we observe? Yeah, use your senses, you look at something, you see how people are doing. You purely observe, you don't put yourself and introduce a treatment. And so with observational studies, you measure variables that are in the process. You know what's going on. But you don't intervene. And so there's a very close relationship between these two. And the biggest difference is that in observational, you stay away from the study and you don't intervene. You don't do anything with them. Say I'm observing a pack of gorillas and seeing how they react in the wild. I'm not going to go in there and give them some natural food source and back out, right? I'm only going to see how they observe in their natural settings. In an experiment, I want to control for all other variables and figure out, does my one treatment influence my response variable? And so recently we've been talking a whole lot about observational studies. So what's one type of general observational study that we took a look at last week? It was the main thing that we studied last week.
Was it the Clincost experiment about talking about certain influences of academic performance? Or is that on Tuesday we're talking about?
I'm just talking about, this is surveys in general, observational studies. So, do you control anything in a survey? Well, yes, you control what questions you ask, but you're not going to set aside one group of people and change something about them and set aside another side. In this observational study, we may separate these into different groups, and you may think that's a type of explanatory variable, but in this case, this survey acts as an observation tool that we do in these cases. Another one is just observing groups as they interact. If you wanted to observe groups on campus and see how different groups talk to each other on Gobbler Connect or on Reddit or any other type of social media site, and you don't intervene, that's the type of observational study. So keywords here, or not actually intervene, but don't intervene, and experiments is this treatment that we're looking at. You're physically changing something about the system. And so just in some less words here, speak in the languages of research studies. So observational, they observe or question participants about opinions, behaviors, or outcomes. And the key word is they don't assign any treatments or conditions. So when you sample, and if you're doing stratified sampling, cluster sampling, multi-stage, simple random sampling, that's not a treatment. That's a way in which you're sampling in the observational study. And they're not asked to do anything differently, specifically in this. Where in experiment, researchers manipulate something and measure the effect of the manipulation on some outcome of interest. So we're talking about testing products on an animal. If I'm giving one animal the drug that supposed, helps them heal faster or helps them, they don't have to eat as much drive or something like that. And then you give the other people the placebo, you're specifically manipulating the drug that you're giving them. And then you're measuring the effect of the drug on your response, whether it be how much they eat, how much they run, what is their general health, and so on. And so a specific type of experiment are randomized experiments, where you want to eliminate specific researcher bias. So suppose I'm in this testing products, and I know I'm testing this on mice. And I have one group where the mice are happy, and they're happy doing everything, and they're in a great community, whatever. And I have a second example where suppose mice are just generally angry and disposed. Now, a great way of doing randomized experiments is to randomly assign the drug and treatment, the drug and control, to a combination of those two categories. But if I'm a researcher and I want my research to be published, maybe I do my drug on my happy mice, and I do my control on my sad mice. And so the only effect I would be measuring in that case is not the difference of drug and control, but happiness to sadness in this case. So in most of the experiments, you need to randomly assign in order to prevent any types of biasing that you might naturally incur. And sometimes you can't conduct the experiment due to practical or ethical issues. So like talking about the type of issues in maybe a cluster survey, where you can only grab one set at a time with limited resources. You could also have limited resources with the experiment, and you could maybe even have just a smaller set of the happy mice compared to the sad ones, and so on. All right. There's a difference between experimental and observational study. Make sense so far? All right. Well, I'm going to propose some situations to you guys, and I want you to let me know if it's an observational study or an experiment. And I'll leave this on the boards just so we can compare to. So, suppose I took note of Virginia Tech football games in 2019 and 2020, and I record which football position scored a touchdown at any particular point. And so I compare all of the 2019 and 2020 by position to all of the ACC. Touch that cord. All right. So would this be an observational study or an experiment? Yes.
Observational, because you're just writing down the statistics that were already based on cornerback, wide receiver, and running back.
That's right, yeah. So I'm not even changing anything to the football team. So if I was giving particular people in the football team, let's just say, to let them worry about their classes and whatever, I gave, some of them 3 classes, and I decided to give some of them 5 classes. Now that would be an example of an experiment where I'm controlling that. But as you can see here, I'm not controlling anything in my reporting. Great point. Well, suppose I conduct a survey that aims to see if the number of siblings someone has influences GPA. And so I survey 100 people in each grade level of Virginia Tech. Would this be an observational study or experiment?
Observational.
And why is that?
It's because it's a survey, so again, like you're not like checking. I mean, you're not changing anything. You're not giving them another sibling. You're just.
Well, I'm sampling 100 people, so that should be an experiment, right?
No.
That's right. You didn't get confused on that. So this is where I see a good bit of confusion possibly pop up. Is that you're doing a survey and you're just like, okay, because I know which people I want to select. If you select those in a random way, you're not conducting experiment. If you're like experimenting, like you're changing each person's grade class, so like maybe you give them, you ask the teacher in each class and you give them extra credit points based on what grade they're in. That would be a type of experiment with the study. But in this general survey, I'm not changing anything about them. And so what if researchers aim to see how food influences behavior? So I have 30 people in my study, and 15 eat only meat, and 15 only eat vegan for 2 weeks. And then they measure behavior before and after. So is this an observational study or experiment? What do you guys think?
Experiment?
I heard experiment from over here. Said that?
Yeah, she said that too.
Oh.
But yeah, I mean, measuration treatment is that you're assigning certain group of people to do one thing, and certain people to another.
Right. So I'm specifically controlling their diet, right? So I assign 15 people to eat meat and 15 eat vegan. Now, a way that this could become an observational study is suppose I monitor 30 people and I just monitor their eating habits for 2 weeks and measure behavior before and after. Now, that's just an observational study instead of experiment because I'm not influencing their diet. You guys see what I mean? Great. So let's talk about, who are we talking about being measured in these experiment or observational studies? So when I talk about a unit, and I'll write some of this on the board too. Are you guys good with this? Can I erase? Okay. Alright, so unit. So when I think of the unit, I think of what I was talked about in elementary school when I'm talking about centimeters or millimeters or kilograms or meters or whatever I'm talking about. I think about that as the unit, but in this case, it's a single individual or object being measured. So in our observational study about Virginia Tech football players, what would be the unit in that case?
Football player?
Yeah, so each football player, right? So if I have 3 running backs, it's each one of those running backs. If I have 15 football players that I'm looking at that score a touchdown, each one of them is a unit in my observational study. And now if you do it, so in an ob study, this is just a unit. But if you do this in an experiment, like I was looking at those 30 people who have their behaviors altered by way of having a different diet, then we call this an experimental unit. And so then you get another type of arrow that pops out of this. So generally it's this. So generally. But if they're people, then you refer to them as subjects or participants. And so these are just a couple of units that we refer to when we're talking about any particular observational study or experiment in general. And so one thing I talked about before is this type of explanatory variable influencing a response variable. And so if you guys remember, going back to where we talked about the simple linear regression and talked about these scatter plots, what is traditionally the explanatory variable? Is it the x or y variable? What do you guys think?
X variable.
X variable, yeah. So X variable, one that's traditionally, so usually we'll have the explanatory here, and then we'll have the response up here on the y-axis. And it's no different talking about this. However, the explanatory variables in an experiment are the ones we physically change. And so when we're talking about independent variables against dependent, independent are the ones that I can control. So talking about people's diets I can control, talking about whether I give a person a specific drug treatment or placebo control, I also influence that. What I don't influence directly is their behavior, is their response to that drug. And so it's called the response variable because we try to aim that the explanatory causes or influences the response variable. And through an experiment, we can determine if it causes, especially if we change the variables without having other variables influenced. And so when we talk about influence of variables, we talk about this one type of variable called confounding. Has anybody heard the word confounding being used before? Just generally, not even in a study. So a few people out here. So confounding variable. And so a confounding variable is one that affects the response variable and is related to the explanatory variable. So we'll take a look at one or two examples. And so when we think about a confounding variable, we also think about a lurking variable that is kind of paired in this. So lurking is a special type of confounding. And it's a special case is that it's not measured. And so in a confounding variable, you might actually measure what this is in a potential problem. Lurking is if it does influence and that you don't even know what's going on. So suppose you want to find out the relationship between sunburns, and ice cream consumption. And then you conduct this this study and you see that there's a higher ice cream consumption is measured with a high probability of sunburn. So do you guys think that the more ice cream I eat, the more I'm susceptible to having a sunburn? No. Right. I mean, if I was, I would literally have third-degree burns right now because I love ice cream. So what is a potential confounding variable that we're not noticing in this case? What is something that could influence? So I have the response here, and I have the explanatory for sunburns over here. What do you guys think? Yes?
The season.
The season, right. So that's one potential. Come back to that. So I would think summer and late spring influences more ice cream consumption because it's hotter, right? And so directly, this confounding variable that we're not noticing is temperature. Because one, temperature when it's hotter, the sun's out there longer in the day, especially during the summer. So I think the seasons are very highly associated with temperature as well. But if I include this temperature variable, I know that temperature influences sunburns. And temperature also increases ice cream consumption because we get hot, we want to cool down, and we can do that by eating ice cream. And so just talking about another example of confounding factors. Let's see. I'm just going to erase this over here, if that's all right. So one example, and specifically, two variables are confounded when you can't tell which one or a combination of two had an effect on the outcome. So one example is you want to test fertilizer on a lawn. You want to test fertilizer on a lawn. And so suppose this is my front yard. I have a nice little front porch right here. And suppose, I have a chair with some seats and a little table and so on. But it doesn't really matter, because I split my yard in half, where I applied fertilizer to half of it, and then I leave the other one with none. So no fertilizer even applied. Yes?
Isn't a lurking variable the definition of when you said you can't tell what the variable has on the effect of the outcome because it's not written in the problem?
Well, you can measure a confounding variable in your study. So the big difference is that you measure a confounding variable. Lurking is one you don't measure, but you know has an influence.
Okay.
Does that make sense?
'Cause you say when you can't tell which variable has effect on the outcome.
Mm-hmm.
So if we take a Venn diagram, A affects B, but if there's a lurking variable, which is a dotted line, that affects the outcome of B, wouldn't that be the lurking variable? Because you can't directly tell that it's affected, but it is because it's outside the factor.
So I guess just the biggest difference is that the lurking is that, if you think about somebody lurking, you have a head pop out of a sheet or something, and they're looking around this way or this other way, they're trying to stay hidden.
Mm-hmm.
And so lurking is confounding, but it's hidden. And if you think about the Venn diagrams, you could even have both a confounding variable and a lurking variable that influence your response, but you don't know in which way or another.
Okay.
I hope I got your question.
No, yeah, you did. It's just I think the wording of the definition of like the confounding variable where you can't tell which variable has the outcome. I think that's just a little unclarifying compared to like lurking variables like own definition.
Right, yeah. So like, basically, there are, it's like if you have confounding, you know, in this bubble here, and then you have, you have lurking inside of this.
Mm-hmm.
Where this part is that you can't see it and you don't measure it, and the rest of this is that you do measure it.
Okay. Thank you.
Any other questions? All right, so let me get back to my fertilizer thing. So I'm going to spread my fertilizer on the blue side, and I'm going to have nothing applied to the other one. And so suppose that the sun mostly hits this side. So I'm going to have a nice little sun that pops up over here, and all this part is in the shade. And so now, if there's more sunshine, then grass is going to grow naturally on that side anyway. And so in this case, we have a side. So side, I'm going to call this side 1, and this is side 2. And so side 1, there is shade and no fertilizer. Where we talk about side 2, where there is sunny, so sunshine, and fertilizer. And if I get results back from these two groups, I don't know if the difference is due to my fertilizer, what I want to try and control, or whether it's due to my sunniness or shade. And so a way to set this up that would be better in an experiment is to take some subplots within this, do nothing with part, fertilize this, don't fertilize that. So now I have equal categories of amount of area that has shade and no fertilizer, shade and fertilizer, sunny and fertilizer, and sunny with no fertilizer. And in that experiment, I can identify what variable is influencing growth. Does that make sense? Okay. And so, talking about lurking variables a little bit, just some more information. Lurking variables are additional variables that create the impression that the variables you study are related when they may not be. And so they could have an impact on every other variable in your study. And so let me come up with another example here. Am I good to get rid of this? So that was an example of a confounding factor that I did measure, is that affected the sunshine. But suppose we have countries with fewer TVs have shorter life expectancy. And so this is just a general conclusion that I get from my study. So what could be a lurking variable? I've only measured here what countries have fewer TVs, and I know what each country's life expectancy is. So what are some examples of lurking variables that I haven't measured that could confound this result? Yeah.
Like amount of like electricity, or like how developed a nation is.
That's right. So that's two great ones right here, electricity. And then development of a particular nation in general. So development is very highly associated with life expectancy, so you would generally tend to find that. But what other things that we didn't measure could be influencing life expectancy along with having fewer TVs?
Medical history of a person.
Of a
Person who could have a shorter life expectancy.
Yeah, so we could think about, I'm going to extend that a little bit because the units in this case, we're looking at different countries. So I'm just going to extend that to medical development. And then as you can see, electricity is highly associated with these as well. And so some other ones are thinking about economic well-being. That could be one of a particular country, also associated with development. And then standard of living of a particular country. So all of these variables are not measured in my general statement that I found here. Now if I were to publish this, somebody would come back and say, hey, you did not measure any particular development or medical personnel of your particular countries. I don't think your conclusion is valid. And so in that case, you have to go back to the writing block and record more information along with your studies. And so one example where we're taking a look at these confounding and lurking factors is through taking a look at book prices. So I brought up the countries with fewer TVs. I brought up the fertilizer, and now we have this situation where a professor has 18 books on their shelves. So imagine a bookshelf that is not curved, because bookshelves do not do that. And then I have just various, this is not a histogram, this is just my books. And so I have that all the way down. And suppose I sort them from the number of pages smallest to the number of pages biggest. And so do prices increase as you increase the number of pages in a book? You might think that it's more expensive to print a book that has more pages in it. So beforehand you may think, oh, okay, as prices, as pages increase, price increases. But as we found here, there are many books with fewer pages that are more expensive. So what could be some type of confounding variables that you could try and study in this? So I thought about a couple ones before class. I just want to hear what you guys have to say. Yes?
It's a hardcover.
Ah, that's a good one right there. So hardcover or softcover? Or I think it's called paperback, not soft. So hard/paperback. Right, because you can just imagine when you go and buy these books online, a paperback is like half the price of a hardcover. And so when you're not measuring that in here, it could influence the results. What other variables? Yes?
This could be a stretch, but do you think font size?
Yeah, possibly, yeah. Especially more they can print on a particular paper. So you think about what influences price: ink, cost of manufacturing the book, and cost of delivering as well. And so for some of these prices, they may automatically take into account how expensive it is to ship a particular book. Because if I were to ship this on FedEx right now, it would probably cost at least $20 in like some type of low quality box or whatever, because it's so heavy. All right, and then let's look for one more. What other could be a confounding factor in this study? Yes?
If it's like written well.
Yeah, so just quality, right? Quality of the book. So you see plenty of books out there that are on the New York Times bestsellers list. And as we know in economics, supply and demand regulate each one another. And so if demand for a book increases as a result of quality, the price is also going to increase. So what I have here is the fewer the books, the more valuable here. And when we take into account this factor, we see a scatter plot that shows yes, especially for paperbacks, as price increases, as pages increase, price increases, but some type of complicated relationship with hardcover. And so depending on what type of book it is, the pages influences the price differently. All right, now I'm going to talk about just some general types of experiments in these cases. So we've talked about different observational studies, talked about explanatory and response variables. What are these experiments and observational studies? In addition to identifying confounding and lurking variables. going to bring up this type of randomized block design. And so this may be pretty complicated to look at. I'll explain each part. Let me just put this on the board. Journaling with each step. Same thing up here. So have any of you heard about a randomized block design in the other classes? So randomized block design takes into effect a randomized design that incorporates a blocking factor. And so in this case, we're trying to look at students that are diagnosed with clinical anxiety, and then it splits off to male students or female students. And so in this case, what do you guys think is the type of blocking factor or blocking variable in this? Well, yes.
Sex.
Yeah, sex, gender, going on here. So, sex is male or female here. And so one thing in the previous study that we took a look at about the books, one type of nice blocking factor would be there if you took a look at soft and paperback books against hardcover books as well. And so in this case, what you do is that I want to find out about anxiety. And so I split it into male and female. And so at the second step, I randomly assign a whole set of population. And so this is where the idea of the surveying comes in. You could either do your type of cluster survey stratified between other factors within this. But here it's just doing random assignment. And so let's just say randomly get 30 from male and 30 from female. Then I can identify from the 30, I can identify my experimental treatment, where I have one half of the males taking an anti-anxiety drug and half taking a placebo, and the same thing with the females. So we're going to say A is the drug and B is the placebo. And so what would be one type of conclusion that I would find from this randomized block design? What could I possibly find from this? So one potential outcome that I could find is that suppose within males, the drug works, there's a difference in the two treatments between A and B. So difference in A to B. And suppose within females, there is no difference. So through this randomized block design, if I had not done my blocking factor as gender in the beginning, I could have found no possible results because all the male and females are interactive with one another, and you may not find the smaller difference within males compared to females. All right. So I think I'm just gonna end today. I got 5 more minutes. So how do we design a good experiment, and who is in one? So like I talked about with, and this is called the randomized block design. So the randomized experiments can allow us to determine cause and effect because we control where we give some type of information to these participants we have so with random assignment, we can make the groups approximately equal in all aspects except the explanatory variable. So in the randomized complete block design, the treatment is explanatory. And so this variable over here is potentially confounding, but we take care of that by splitting that first off. Then through the random assignment, we can reasonably conclude that the only differences between these group of people in here is only their treatment effects. And so we want to make sure that explanatory variable is the only changing variable within this. If you go back to that fertilizer story, I changed 2 variables in these 2 groups. I can't tell if it's due to one factor or another. And we also know that participants in randomized experiments are often called volunteers. So if they volunteer to do a particular medical study, they might get some money from it. They're still called a volunteer even though they're getting paid for this. And then lastly, the fundamental role, we've talked about this before, but available data can be used to make inferences about a much larger group. And then if the data is representative for one, so if this data is representative to the group as a whole, we can make a conclusion about the drug will work generally on males in this case instead of females. But it has to be representative about the question of interest. So when you're doing this, you have to, one, is there a difference? And then 2, representative to the question. So it needs to be to the question, representative of the population you selected as a whole. All right, so it's 2:13. I'll let you guys have some 2 extra minutes. Are there any other questions about exams or anything else before we get out?
That entire video was just